This is a lecture about solving a quadratic equation by completing the square of that quadratic equation. So let us first review about the square part, and this is one example of a perfect square, and we're going to use this, a plus b squared, and turn that general quadratic equation to a power equations. Let's review what happened when you expand this a plus b squared. And if you write it vertically like this, it's really easier to understand. And I copied this a plus b 2 times, and you have to multiply out all these each two terms with the other each two terms. So there are 4 possibilities, combine multiplying these two and that two and cross like here. By doing that, we have these terms. By multiplying this AA, we get a squared, BB, you get b squared. By cross multiplying, we get this 2 times AB, and which is written here. So if you multiply a plus b 2 times, this is what you get. So let's apply this to the equation form, and when you solve equation, you have x's in it. So and it's the key thing is that you're pulling this x plus a squared, the perfect square, out of the equation. So let's apply that a plus b formula to x plus a squared. So instead of a and b here, we have x and a. So if you apply that binomial formula that we had before, and this is what you get, is a squared 2 times ab plus b squared. But usually we write that a variable later, so it's reorganized like this. So you can do that cross multiplication again with this x plus a squared, then you get these 3 terms show up. So you can verify it like this, x plus a written down here. So here's the key thing. If I write it like this, x squared plus 2ax plus a squared, and right next to it x plus a squared is written, then you believe this is the statement. The thing is that you will be looking at this type of expression, not knowing that, not written in the form, so that you recognize as how this part of the coefficient is related to that part of the coefficient. So you can see this is 2a and a squared. So they're not like totally independent. They're somewhat related. So as soon as we can recognize that, we can go back to that shape. So let me describe the relationship between these two numbers. So first, the relationship is going to be a process. You take that number you see in front of x. Suppose you don't see that as a 2 times a. So how do you pull an a out of it? So if you see this entire quantity, if you divide that entire quantity by 2, which is halving that coefficient, and you will arrive down here in a. So this is, suppose this is happening in your mind, so that's why I use this extra space, a in there. And what is the relationship between this quantity and then quantity you see out there as a constant term? So definitely we're squaring it. So you see a number in front of x, take the half of the quantity, then you square it, which is written as a procedure here, half it and square it, and you're supposed to arrive at this number you see there. So if this is perfect match, then you are looking at the perfect square form. So if you have these 3 terms, and with this relationship, we can replace that quadratic polynomial with this perfect square form. So let's have a look at example. For example, like this, x squared plus 2x minus 5 equals 0. So we're asked to solve this equation. You may try to factor this and realize that there's no way to factor this nicely with the integer coefficients. So next attempt will be this completing the square. What we're going to do is just to see by sheer luck, see if we're in the perfect square form. We're going to take the half of this quantity and square it and see if that's in that relationship. So if you have the coefficient, it's going to be 1. I divide that 2 by 1. And if you square that, I halved it, and if I square that part, you only get 1. So abbreviated with SQ, if you square it, you get 1. And that you can see that number is not the same. So we're not in a perfect square form. That doesn't mean we cannot use it, so here's how you use it. So first we're going to move that 5 to the other side, so we have x squared minus 2x is plus 5. Then left hand side does not have a constant term, so the constant term we wanted to have so that this one turns into a nice perfect square was 1. So I wrote it here like this, and if you have this coefficient, I think I missed that, it's supposed to be positive 2. So we have that now. So that's 1, and if you square that, become a positive 1. So we want to have that 1, but there's no coefficient before. So if you add 1, then you have to add the same number to the other side, such that this equation remains the equivalent to the earlier one. So what just happened again is that this negative 5 is not the correct coefficient, so we got rid of it to the other side, and then we insert the right coefficient, such that this coefficient in front of x and the constant term in the left-hand side is this good relation half n square. Whenever you see this half n square, then it is going to become perfect square. So I wrote it here, and we are in this perfect relationship in the left-hand side. So what happened to this one is magically turns to a perfect square. Like this, the right-hand side is a 6, left-hand side, and with this number a, remember that was supposed to be 2ax, and a shows up and as a number inside the perfect square. So this diagram here is the summary of what happened if you square x plus 1, and then we recognize that these two numbers in the correct relationship because we make that last number have the relationship. Then what goes inside the perfect square is this number half the number was 2a and a squared before, so a goes in there. If you don't remember this relationship from earlier slide, it seems like I'm just making things up, but this is where the magic kicks in. This is actually the quick way of factoring these particular polynomial. And that factor is the same factor, so it became perfect square like this. Now this, since this is a power equation, from here solving just uses radical, especially the square root symbol. So x plus 1 is a root 6 or negative root 6 because it's even power there. So that's why we wanted the power equation, perfect square, where we can use this radical symbol. So if you solve these two cases individually with for x, we have one root negative 1 plus square root of 6, another one negative 1 minus square root of 6. So here's another example, x squared minus 5x plus 1 equals 0. So this again defies the factoring method. So what we can do is we can move this 1 to the other side, which is going to be this negative 1, and we only have x squared minus 5x on one side. So we have a freedom to have some nice constant here, such that this turns out to be a perfect square. How do we do that? We take the coefficient of x, which is negative 5, and take the half of the quantity, which is negative 5 over 2, and square that and put it in here. Then this will be a perfect square. So that number is 25 divided by 4. If you square that, this negative becomes positive. And you have to add that 25 divided by 4 here as well, which is added here, so this remains the same. So to simplify, you put in the common denominator negative 4 divided by 4, and that'll be 21 divided by 4. So altogether is this number, which is, this is supposed to be 2a, and that's supposed to be a, and that should go inside the perfect power. So that goes to negative 5 over 2, 5 over 2, that whole thing becomes this perfect square, and the right-hand side simplifies to 21 divided by 4. So that's a power equation, so x minus 5 over 2 is the square root of this one, or x minus 5 over 2 is negative square root of that one. So it leads to following solution. Okay, that's an example. So let me discuss this last example, and which looked like this: 2x squared plus 8x plus 1 equals 0. Again, this will defy the factoring method, so we decided to go for completing the quadratic, completing the square. What you had to do just to handle this case, just like before, is that you just simply divide everything by the coefficient of x squared, which is 2. So if you divide it, then you have 4 as the second coefficient, and last one becomes 1/2. So from here, it's going to be exactly the same as before. So move this positive half to the other side, becomes negative half. Then we're going to have this coefficient, which is 2. Then we're going to square it again. This is squared. Then that's 4. So we have to add this 4 on the other side as well. So we have this 4. If you combine these two, you will have 7 over 2. And we'll have this equation x plus 2 squared. That's going to be a perfect square. That 2 goes inside there. Right hand side 7 over 2. So power equation. So we have x plus 2 positive root over 2 and negative square root 7 over 2. So by solving it. So that concludes the lecture about solving a quadratic equation by completing the square. Thanks.